Okay, so today we're going to talk about just inverse quadratic functions, the ones that we learned about the other day. You have to restrict the domain when in order to make it a one-to-one function, so that the inverse is also a function. So a function whose highest power is 2. Quadratic is a function whose highest power is 2. Remember when we talked about degrees, the parent function was y equals, or f of x equals x squared. And you could write it in vertex form like we've been looking at, x minus 2 squared plus 1, or sometimes you see them in standard form, 2x squared minus 6x plus 3. And you can solve that using the quadratic formula. This we're looking at so that we can get the vertex. The vertex of this function right here is going to be the opposite of this number, so it's going to be 2, and the same as this number, so 1. So this is the x value at the vertex, and this is the y value. And we call this number h and this number k. And we're going to need to know that for today's lesson. Okay, so this number here is your k, this number is the h. Okay, so not all functions are naturally likely to have inverse functions, and quadratics don't pass the horizontal line test, so they're not a one-to-one, or they don't have an inverse. They fail the horizontal line test. So the horizontal line test, just to review, is a function whereby it is one-to-one, and its inverse is a function if no horizontal line crosses its graph more than once. So in the case of a cubic function, this cubic function, not all cubic functions, but this one, the graph is, all these horizontal lines, none of them cross the graph more than once. So this is one-to-one. Well, I can write it up here. And the quadratic, however, because it crosses the graph, this horizontal line crosses the graph twice, as does this, the only one that wouldn't would be down here, or way below, all the way below there. But if any horizontal line crosses more than once, then it is not one-to-one. So it's not 1-to-1, so it's not invertible. Now, how do we make it one-to-one? Well, if you remember, we just took out this half of the graph, and we made it one-to-one by eliminating that whole half of the domain. So all the x values below this vertex, below the vertex, is eliminated from the domain. So we know the x value at this vertex is 0 because it's on the y-axis. So if everything below x equals 0 has to be eliminated, we would say the domain would be x is greater than or equal to 0, or we could say from 0 to infinity. Different ways, the two different ways we've talked about writing the domain. Okay, so to review how to find an inverse from last week, not just yesterday, you replace f of x with y, switch the x and y, then solve for y in terms of x, and last we put that f inverse x instead of y in there. So it's really key to switch the x and y and solve for y. So let's look at this function. Find the inverse, state the domain and range of the function and its inverse, and then we're going to graph it. We'll do that last though, so I'm going to put that down here for now. Okay, so find the inverse. First, let's write it in vertex form. Remember, vertex form is x, a times x minus h squared plus k. And the vertex is hk. So knowing that this is minus h, but the positive, so take off that minus, anyways, this number h at the vertex can be the opposite of this number. Well, looking at this, I don't have anything with that x squared. So that's like saying x minus 0 squared plus 2. The 2 is your k. Okay, your constant term is always your k. The thing in the parentheses with the x is always your h. But if there's nothing in the parentheses with the x, in other words, you have just an x squared, h is 0. So in this case, my vertex is 0, positive 2, because the case is the same sign as that. Okay, so since I know the vertex, I can find the domain because we just said it's going to be at the vertex. The domain starts at the vertex. We eliminate everything to the left in a positive quadratic function. This is positive because the coefficient of my x squared is positive. So the domain for my function f of x, the domain would be x is greater than or equal to 0 because x is 0 at the vertex. The range we just take from the k. Remember, the bottom of a quadratic function, if you shift it up, then the domain shifts up also. The bottom of that function is now at 2 instead of at 0. So the range, the lowest y value is right here at 2. So y is greater than or equal to 2. So whatever that number k is, that tells you your range. Whatever h is tells you your domain. Hey, we talked about that in the notes the other day, but just a little refresher. So this is your vertex form. Okay, so we know the domain and range of the function. Now, to find the domain and range of the inverse, it's just the opposite. You just basically switch these two numbers. So for f inverse of x, the domain and range switch. Because we're switching x and y, the domain and range will switch. So x is greater than or equal to 2, so I took this 2 and made it my domain, and y is greater than or equal to 0. So they just flip. See how they're flipped? The domain starts at 0 for the function, but the domain starts at 2 for the inverse. Range starts at 2 for the function, and 0 for the inverse. Everything is just switched. That's the whole thing about inverses. Everything just switches. Okay, so what is the inverse of this function? Well, let's go back up so I can see the function. X squared plus 2. So I have, remember this gets changed to y. Whoops. This gets changed to y, and then I switch x and y in the function. So I have x equals y squared plus 2. I need to get y by itself, so I'm going to isolate this, and then I'll end up square rooting, it looks like. So subtract 2 from both sides. Remember, both sides of the equal sign. Okay, so x minus 2 are not, those are not like terms, so they stay separate. These go away, and I just have y squared on this side. And then I take the square root of both sides. When I square root both sides, I end up with square root of x minus 2 on this side and y on this side. So my inverse equals square root of x minus 2. Now, I want to graph this, but I need some points to graph before I can graph this. And I want to get them to be about the same points. So the easiest thing to do, I mean, you could put them both in your calculator, but you want them to be the same comparable points when you graph them. So the easiest thing to do is take your vertex, 0, 2. Okay, start at the vertex. So that's going to be your first x and y value. So 0, 2. And then just count up. Since all the x's have to be greater than 0 according to our domain, the next x value would be 1, and the one after that would be 2. If the domain started at -1, you'd start at -1, then you'd have 0, then 1. Now these you have to plug into the original equation and get your y values. So in other words, f of 1 would be 1 squared plus 2. Well, 1 squared plus 2 is 3. And f of 2 would be 2 squared plus 2. I'm just plugging it into the original equation. So 2 squared plus 2 is 4 plus 2 is 6. Okay, so there's the f of x. But I also need points for the inverse. Well, all you're going to do is switch. So 2, 3, 6, 0, 1, 2. You just switch the x and y values to get the inverse. Now I can graph. Okay, so the first one, 0, 2, then 1, 3, then 2, 6. So there's f of x. And then the second one is 2, 0. Do that in orange. 3, 1, and 6, 2. See how they're flipped? Remember this is supposed to be flipped over the line y equals x. So the line of symmetry is right here, x equals y. I always plot 0, 0, 1, 1, and 2, 2. Always. This is always part of the graph because that's the line of reflection, not line of symmetry, line of reflection. Your line of reflection is always x equals y. So that's always going to be part of these graphs. So x equals y, and then this is the inverse. We always label the graph so that we know what we're looking at. Get this out of here. So, or put a bare. So I'm sorry, it's all so close together, but there's your graph of the function, its inverse, and the line of reflection. So now I'm going to have you try one. Flip over your paper, and I want you to go to under the try it. Don't go to number 2 on top. Go to the middle, the try it. That's the only one I'm going to have you do, and then you do your assignment. So f of x equals x minus 1 squared minus 1. Try to do it as much as you can without my help. So I'm going to write down the steps. First, you're going to find the vertex. Then find the domain and range of f of x and the inverse. Then find the inverse. Make your tables. Using vertex points, and then graph. Don't forget line of reflection. F of x, the inverse, and the line y equals x. Graph all three of those. That's all you're doing. And it seems like a lot, but once you do a couple of them, my students said the same thing, it seemed like a lot, but as soon as they did a few of them, they thought it was easy. It's just a lot of steps. So there's only 4 problems on your homework, so that's why, because there's several steps to each one of these problems. So stop the video, try the problem, following the 5 steps. Okay, so the first thing you needed to do was to find the vertex. So for this function, the vertex is going to be the opposite of this number, so it's 1. H is 1. And the same as this number, so negative 1. So that helps you get your domain for f of x. The domain will start at this number. So the domain is x is greater than or equal to 1. The range starts at this number, so that's y is greater than or equal to negative 1. And then for your inverse, you just flip. So domain is going to be at the negative 1, and the range is going to be y is greater than or equal to 1. Okay, now I need to find the inverse of that function. So we've got x equals y minus 1 squared minus 1. And I need to solve for y, so I need to add 1 to both sides first. Remember, don't worry about the parentheses till you undo everything outside the parentheses. So these go away. I have x plus 1 equals y minus 1 squared. Now, I don't add this 1 yet because I still have a power. We're basically doing order of operations backwards. So remember PEMDAS, P, E, M, D, A, S. We undo addition and subtraction, then undo multiplication and division, then undo exponents, then undo parentheses. So you're going to square root both sides first, then deal with what's in the parentheses. So we've got x plus square root of x plus 1 equals y minus 1. Now I can undo that minus 1 by adding 1 to both sides. Now since I added the 1 after I did the square root, that 1 is not going to be under the square root. That plus 1 will be outside the square root. And there is your inverse function. Square root of x plus 1 plus 1. Now I just need a table so I can graph it. Table for f of x. My vertex was 1, negative 1. So I'm going to go to 2 and 3 and plug those in. And for 2 I get 0, for 3 I get 3. And then the inverse, just switch my x and y's. And then plot the points. So we're going to move that graph down. Well, maybe I can just go back up. If you have your points written down, I'm just going to go back up and plot those points. Hopefully you got those written down. So I've got 1, negative 1. 2, 0. And 3, 3. So that's f of x. And then I'll do the inverse in orange. So I've got just the opposite, negative 1, 1, 0, 2, and 3, 3. So these are going to cross. They're kind of different than the ones that we did first. And then we've got our line y equals x going through the middle at 0, 0, 1, 1, 2, 2, etc. I'll write it down here, x equals y, and you're done. I do want to show you on your homework a couple things. Actually, just one thing. If you look at the functions, there's only 4. You're going to do all of these things for each one of these 4 problems. First, find the vertex. So if I wanted to find the vertex of this, what do you think it would be? Well, we don't have a k, so this is like putting plus 0 here. So the vertex would be 1, the opposite of this number, 0. And in this one, we just have a plain old x squared with nothing added or subtracted to it, because the squared is on the x, not the 3. There's no parentheses. So that means my h is 0, k is negative 3. So I just wanted to start you out on that. Okay, that's it. Try it. Oh, I know why. Sorry. There.